All right, welcome everyone to Innovation Flow Podcast. We are here on location at WEFTEC in Chicago, the biggest wastewater conference, I think anywhere probably.
So, yeah.
And I'm here with Bryan Coday, my guest for this episode. We're going to talk a little bit about side stream enhanced biological phosphorus removal, and that's where I'll stop and turn it over to Bryan. But maybe, Bryan, can you give us a little background about yourself?
Sure.
I should introduce you a little better.
No worries.
You're Bryan is the lead principal technologist, associate vice president at Carollo Engineers, and he's been working on a project with South Platte Renew on biological phosphorus removal. So, yeah, why don't you tell the listeners, the audience, a little bit about yourself and your background?
Yeah, I think you hit the nail on the head. I'm out of our Denver office, been there 10 years now. Serve as our wastewater tech practice lead for the Rocky Mountain region in the Midwest, and then I'm our innovation lead for the central U.S. and up into Canada.
Nice.
Yeah.
I bet does that keep you busy?
It does.
Yeah?
It does, very much so, but it's a lot of fun. There's a lot of cool things going on in the industry.
Do you think this technology, it's a technology boom in the wastewater industry, or do you just think that we're just now into it, or do you think it's growing?
I think it's growing, and I think the pace at which it's growing it's increasing exponentially. So
Yeah.
I think we're going to continue to see a lot of cool innovations coming out that drive what we can do with what we have.
Yeah, I feel that way too. It seems like we're in this sweet spot of innovation, but I thought, well, maybe that's just because that's where I'm at Micro, and it's
Sure.
always been like this. But I'm glad to hear you agree that we're in a golden age of innovation, I'd say.
It's a fun industry already to be in, but with everything going on, it makes it just that much more exciting.
Yeah. Well, we're here to talk about biological phosphorus removal, and in particular, side stream. And for our audience, our viewers, maybe just take us through what all that means.
Sure.
Just the general principles and what we're talking about.
Yeah.
Here.
So, nutrients in general, we know is a big issue in terms of removing them from effluent discharge,
Being
eutrophication,
nitrogen,
phosphorus. So, issues with eutrophication, dead zones, hypoxic zones.
Yeah.
So with phosphorus, that's obviously one of the cases, but it's a little bit of a double-edged sword. So we're looking at opportunities to reduce effluent phosphorus discharges for that reason. But phosphorus is also one of those that it's a finite resource. So not only are we trying to remove it from discharge, but opportunities, identify opportunities to be able to recover it for beneficial use. From a treatment perspective, there's a couple different ways that you can do it. So like South Platte's doing it right now is chemical phosphorus removal.
Yeah.
There's also opportunities to do it biologically. So based on the work that James Barnard's done years ago, identifying ways where if you have an anaerobic zone in the mainstream followed by an aerobic zone, you can condition the biomass in the system to remove that phosphorus biologically. So in that anaerobic zone, you have a certain type of biological community, phosphorus accumulating organisms. They'll release that phosphorus, they consume some of the carbon coming into the basin, and then in that downstream aerobic zone, they take that phosphorus back up in excess, and then you can waste it from the system.
Okay.
And when you do it biologically like that, it helps to open up opportunities where you can recover that further downstream.
Yeah.
Some of the challenge with doing it, at least biologically, historically in the mainstream, is that those PAOs, or phosphorus accumulating organisms, they require a certain type of readily biodegradable carbon, they're volatile fatty acids.
Mm-hmm.
Different facilities may or may not have enough of that carbon at any given time to really help sustain that population.
Yeah.
So that's where you start hearing facilities having issues where BioP works well for certain times of the year, but then other times of the year it may struggle. The other challenge with implementing BioP or EBPR in the mainstream is that many facilities are already set up. They didn't necessarily have the phosphorus limits to begin with.
Yeah.
And to generate that anaerobic zone in the existing tankage, 10 to 15% of that volume that you need to take up of your existing tankage now cuts into the capacity of the plant. Now you're driving the need to potentially expand basins. So it's both a capital and an operational question.
Yeah.
So going into the side stream, there's that opportunity where we have found in more recent years, you can move that anaerobic zone to the side stream, you can ferment carbon internally, be less reliant on the influent wastewater quality coming into the tanks, and presents that opportunity to make BioP a whole lot more resilient as compared to what it has been historically.
Yeah, all right. So it's finicky, and
Can
it's
be.
usually retrofitted.
Yes.
And those are the hard parts. So I think that kind of ties right into the pilot you've been working on with South Platte Renew.
Yeah.
maybe tell us a little bit about how that pilot, answered or tried to help answer some of the questions that were out there.
So South Platte Renew's facility is pretty unique. Obviously in Colorado, I think nationally, it's got a lot of different unit processes that are built on top of one another.
Yeah, it's like Frankenstein together from the 70s on.
Yeah, absolutely.
Which is a lot of plants.
It is. And with the trickling filter solids contact tank process that you have, most of that carbon that you would have needed to do BioP is already being removed.
Yeah.
So the opportunity with the solids contact tanks there presented a nice opportunity to look at taking the 2 RAS reaeration tanks that are there and converting them to an actual true side stream RAS fermenter to be able to do the side stream EBPR. So with working with your staff, they were successful in getting that U.S. Bureau of Reclamation funding to be able to do this piloting, where the way the facility is set up is really opportune. You already have a tank where you can dedicate RAS going through that zone. You have a second tank as well where you can potentially in the future be able to split only a portion of the RAS to be able to ferment and generate an anaerobic zone to do the biological portion on the side stream. So that was the main goal as part of this first phase, was to set up that condition as a proof of concept to see, does it make sense to move away from the chemical phosphorus removal into this piloting. I think one of the main drivers has been the fact that you do phosphorus removal chemically. That's a long-term demand on the chemical.
Yep.
And then also with the effluent discharge limits in Colorado starting to become more stringent for things like sulfates and chlorides, anywhere where we can remove those chemical loads, I think is going to be important.
Yeah. All right. So what, you did this pilot, you reconfigured a basin. What challenges or what'd you come up against that you weren't expecting during the pilot? So
working with your staff the last couple of years, because a lot of the planning with this started with a master plan several years ago.
Yeah.
So ideally with a S2 EBPR system, you don't need to send 100%
S2,
of your...
let's break that down real quick.
So
2 S's, so that's
side stream enhanced biological phosphorus removal.
Okay.
So the S2 EBPR.
I like it.
What we have found is you only need to pass a portion of the RAS through that anaerobic zone on the side stream. With the way that the system is set up now and the timing of the pilot and the way that the funding was procured, there wasn't enough time to be able to look at being able to control only a portion of the RAS through your RAS anoxic zone at this time.
Okay.
So for that pilot, we had to pass 100% of the RAS flow, which reduces the hydraulic retention time in the basin to less than ideal conditions, and also the solids retention time. It also means more external carbon potentially when we were doing the proof of concept. So those were the main challenges. I think that overall we did see benefits. We were tracking the biological community, so we did see a significant shift in the phosphorus accumulating organisms that were in the basin.
Mm-hmm.
We did see an appreciable increase in the phosphorus removal, not to what state of Colorado requires yet, but at least for a proof of concept that there is potential benefit of investing additional capital, money for testing, to be able to really tune in how much RAS we need to send to that zone.
Yeah. That is that's interesting. The whole thing with biological phosphorus, how it grabs the phosphorus, it hogs. I can't remember what they call it, luxury uptake.
The luxury uptake. Yep.
It grabs all this, hangs onto it, and then at a certain point releases it.
It does. Yep. Absolutely.
Yeah, that's always interesting. And the whole idea of we do chemical phosphorus removal now, but getting away from chemicals.
Yes.
And using biology, the natural systems to get us even further down the road is interesting. What do you think is the next steps, or what came of this project? You mentioned you did learn a lot. We did learn it's feasible. What were the lessons learned from the whole thing?
So I think the next steps coming out of that, in talking with the team there at South Platte Renew, there's a lot of opportunities to look at some of this now as we wait to determine what we want to do at the full scale by doing benchtop tests on the apparent RAS fermentation rate. We, as well as others, you guys have done a lot of process modeling. We can now take that information, look at it more at a desktop evaluation to make sure, take it the next step to evaluate what performance we think we can get out of it.
Yeah.
I think we've also been talking with some of your staff about what are the opportunities to change some of the RAS piping, minor capital improvements to be able to do a second round of this and really try to dial it into the ranges that we've seen at existing facilities, really help promote how well this system works.
Yeah. I know you do a lot of modeling, a lot of work modeling plants and systems. What do you? This is a pilot kind of on the ground. How important do you think pilots are to really ground truthing or making sure those models actually work?
I think in general, I think it's important. I think for this particular process, we have found that from facility to facility, we call it the apparent RAS fermentation rate. So for how long you hold that biomass under those anaerobic conditions, depending on the type of system you're running overall, how much of that carbon can you actually release to help drive that BioP process on the side stream? The process modeling softwares out there come with a default scenario, but depending on what facility you're running, that number needs to change. So a lot of that piloting, either at the full scale or doing some of this bench scale rate testing, helps to inform what knobs we need to tune inside the model to make it just that much more accurate. So anytime you're dealing with the biological system, we have a lot of good knowledge historically about what default kinetic and stoichiometric rates and things that go into the model. Anytime we can do site-specific testing, it just makes it that much more powerful for predicting what we need to do at the plant.
Yeah, I'm always amazed that the models are as accurate as they are, because every plant is so different. Operators will tell you there's no two plants alike, and even parts of plants are different. And so
absolutely,
the idea, I get what you're saying. The more specific information about that specific plant that you can feed into that model makes it more accurate.
Yep, between the influent characteristics, how the biology is responding, what type of effluent performance you're getting out of it, it's the junk in, junk out scenario. The more good information you have to plug into it, the better the simulation and the reports are that are going to be coming out of it.
Yeah. So what if we figure this out? What if we work with you? We work with the models. We work with the scientists. Figure this out. What are the benefits? You mentioned permit requirements is a big one that we think about. What are that, and what else do we get out of taking more phosphorus out of the wastewater? So from a capital perspective, because you have the capacity right now, by dedicating that one tank to potentially a side stream RAS, fermenter or an or anaerobic zone, that's one way to potentially implement this biologically that likely wouldn't have been possible with how your system is set up now. So being able to implement it biologically reduces that long-term day in, day out ferric dosing that you're having to do now. So there's capital savings on a basin expansion. It's less reliance on the chemicals that you're having to dose. There will be some other potential capital improvements depending on where the facility wants to go, that once that phosphorus leaves the system, it now goes to solids handling. So a lot of that phosphorus does get re-released. Yeah. That presents the opportunity where you can then install other technologies like a MagPrex or a PFix or an Elevac system and actually recover that phosphorus. Either leave it in the biosolids, which some facilities do like Fort Collins, or there's the opportunity, if there's a market for it, be able to actually recover that phosphorus and use it for beneficial reuse applications. People are buying it all the time, which is part of the problem. Is in fertilizer. People put it on their lawn, washes down the drain, and gets into those waterways, causing the algae. So, if we could pull it out of the wastewater instead of mining it, and get that internal recycling at least through the wastewater system. Start speaking to that circular water economy, and then you said from the permit perspective, I know that when the chemical modification requests were going through for this facility, that was pretty challenging in terms of having to select which chemical works best in terms of meeting your chloride and your sulfate limits. Yeah. So that helps provide more buffering capacity, if you will, with respect to the effluent discharge limits, if we can get rid of the metal, the ferric and the alum salts. Nice. Well, let me ask you this. As the technology innovation lead for a major consulting firm in the industry, how do plants take it when you lean into this innovation? Sure. You say we want to do this innovation. As far as operators, management, plants, are they receptive? Are they, do they push back? Are they? What's that look like for you?
It's a process. I think you have to take it step by step. I think I have found the number one, not challenge but opportunity, I think, is working with ops staff. I think they're the number one folks that obviously have to be running the plants.
Yeah.
They're the ones that are going to have to be maintaining it. Management, make some of the higher level capital decisions, but it really comes down to making the operation staff comfortable with what are the potential solutions that you can implement, and you bring them along every step of the way. The decision making, what's it going to do to the potential process, what are the ramifications for O&M. I think the operation staff is the number one thing to involve from the very get-go on any of these innovation discussions. Yeah,
I think you're right. And then sometimes they have the best ideas.
Absolutely.
As far as how to reroute piping or change things for the better. So yeah, I'm glad to hear that the operators are involved.
Absolutely.
How's your conference been in Chicago? What have you done anything exciting? Seen any sites? How's it been?
Folks, they always say if you do WEFTEC right, you're exhausted by today. So I am definitely exhausted.
Me
I think
too.
I'm ready to go home. I help co-facilitate the microbial microscopy workshop on Saturday and Sunday. So I'm usually here from Friday afternoon all the way through today. But WEFTEC's been great. It's spent a lot of time on the floor this year talking with a lot of folks. It's been a great conference.
Did you go to the Bean?
I didn't go to. That's one thing I haven't been to yet. So I think one of the questions that you potentially was going to ask was the favorite thing in Chicago. I think I've been here 3 or 4 WEFTECs now, and I can honestly say I've not been to the same place twice yet. So I've not been to the Bean. Usually our friend and my colleague Jeff Berlini's always got really good food restaurants, and he puts in reservations months in advance. So unfortunately I didn't get to do that with him this year. But I think the one thing, I'm a big baseball guy, and I think next time I'm going to try to make the effort to get out to Wrigley Field. I've not done that one yet.
Yeah, I think I could see that from my hotel room. I think
nice.
Is it by Soldier Field?
I think so.
I could see something, and I was like, I need to go there and find out what that is.
Yep.
But yeah, there's so much to do in this town, and the food scene. Like if you're a foodie,
absolutely
great restaurants, great tourist art museums. It is everything.
It's been great.
Yeah. Somebody told me when we got here, they're like, this is a tall town. And I'm like, it is. There's just huge buildings everywhere.
Yes.
Denver's got skyscrapers, but this is a whole different feel here in Chicago. Well, cool. Well, I appreciate you being on the show today, Bryan.
Not a problem.
And sharing a little bit about your work with the enhanced biological phosphorus removal and what you've been doing with our folks at South Platte Renew. So, did you have anything you wanted to leave with the listeners, the viewers, before you left? Or
nope. I appreciate the opportunity, and it's been great working with your staff on all this innovation that you guys are doing. It's exciting to see what you and your team have been doing the last few years with this. I'm excited to see where you guys take it.
Yeah, we are too. So thanks again to our listeners. Thanks for watching Innovation Flow Podcast on location from WEFTEC 2025 in Chicago. And if you have any comments on the show, you can get a hold of us. If you like the show, give us a 5-star rating on Apple Podcasts, Stitcher, Spotify is a good one. We get a lot of listeners, or YouTube. We're also on YouTube. And we'll see you next time on the Innovation Flow Podcast.